VLSI lab. So now in this session we will going to learn how to do the 4-bit up down synchronous reset counter. Okay, so 4-bit up down synchronous reset. That means whenever the clock is there, at that time only if you press the reset will going to work. Okay, synchronous, it is synchronized with the clock. So now we learn this in the two platform. One is the ISC design suite, that is Xilinx ISC, and another one is the online EDA playground. Okay, so first one, let's see in this ISC project navigator. Just open this and click on the new project, and here okay, so we are doing the first project, that is 4-bit up down synchronous reset counter. I will just call this as a counter. Okay, and here we will write 4-bit up down synchronous reset counter. Okay, so we are going to write this in okay, so HDL, that means okay, so higher development language, high level, top level source. Okay, so hardware description language. Okay, it is not higher development, it's a hardware description language, and we are going to write in the okay, so the project location is read only, please try. Okay, so that means we just change this location to here, and I'm just going to create one folder, and okay, so we call this as a so Verilog Verilog codes. Okay, so just call this folder name and choose. Okay, so then click next, and we are going to use the okay, so here is the Spartan 6. This you can select this Spartan 6 or Spartan 3E, any board. If you have any board, then just select this. Now we are doing the simulation, that's why I just do this Spartan 6, and these things will be on the your FPGA board. If you have device and this package and speed, these things will be there on the with the it is specifically to the board. So now okay, so then this simulator, all this setup, then click next and again click finish. Okay, so now this is the we are going to use the Verilog language. So so just create the new source, and here there are VHDL and Verilog. We can choose any of these two. I'm choosing the Verilog module. Then here we need to give the file name. I just give this as a counter. Okay, then click next and click finish. So here we have module counter and end module. Okay, always remember, whenever we are writing, we just need to write module, open bracket, close bracket, and the end module, and inside this, okay, so counter, 4-bit counter. So first thing, we need to have the output. One is the output, that is out. We just call this as out because output is a keyword here. So out, and we need the okay, so it is the clock. Okay, input. One is the clock input, and another one is the reset input, RESET, reset input. Then what else is required? So 4-bit, that is the output, synchronous reset counter. Yes, this much is enough. Output, clock, and the reset. Okay, so now we need to specify what is the output and what is the input. So output output is 4-bit, so I need to specify 3:0. That means 0, 1, 2, 3. Okay, so here this is the out, and clock, it is the input, clock comma reset. Okay, and now we just write this using the always block. So we need to mention this output as the reg, that is behavioral modeling. So we just need to define this as a reg output, and here we need to, okay, reg not output, reg, and 3:0 of out. Okay, so now here we need to start the always block. Okay, 1 minute. And another thing, it is the up down counter. Okay, up down counter. So up down counter. Okay, so that's why to choose up or down we need to have another input, that is we just call this as a up. Okay, one switch, it's just like a up. If up is 1, it will count up. If it is equal to 0, then it has to count down, that means count in the reverse manner. So that is the another input. Okay, so now we are using the I told we just we need to use the always block. So here we need to write the always. We are it's in a behavioral like abstraction level, behavioral. There are 4 types actually: behavioral, data flow, gate level, and the switch level. So now we are using like algorithmic level or the behavioral level. In data flow will be, it is like assign and like that it will be there. So here we need to use the always, always, always at, and here since it is the positive level counter, so we need to give pos edge. Okay, so if it is an egg edge, you need to give as an egg edge. So if you want both in positive edge and negative edge, then don't mention positive or the negative. Always at whatever, just mention the clock. Okay, so at that time whenever the clock change, it will going to come inside this block. Okay, so now always at pos edge of clock, it is a synchronous reset. That's why we are not writing reset here, only we are just checking initially the clock, then okay, so begin always at pos edge of clock. Okay, you can just maintain the indentation just to just for good looking purpose. So what we need to do, we just need to check if up, okay, if up is equal to 1. If it is just the one bit, then no need to write 1 tick b 1 like that. Simply write 1, it will consider in the binary only. So if up equal to 1, then what we need to do, so we need to check the 2 things. That's why I am writing again begin and what we need to check, if reset reset, if reset, then we need to what we need to do, we need to assign out equal to tick b 0000. Okay, 4 tick b 0000, or else we can directly write out equal to 0. Okay, all the bits will be 0. or we can just do 4 tick B0, anything is fine. It is followed by the 3 more zeros. Okay, so now if the reset, okay, if reset, then this will be equal to 0. Otherwise else, what we need to do, up is equal to 1, that's why it has to count up. We can just simply write here, if up equal to 1, count up. Okay, so here else we need to increment count equal to count plus 1. We just need to increment count. Okay, that's why count equal to count plus 1, not count. We just need to increment out. Okay, so out, out equal to out plus 1. So similarly, okay, so this we can just have it here. We can just have this here. This is the count up till here. Okay, similarly, what we need to do, count down. So for that one, count down. If up equal to 0, or else we can simply use else. Okay, instead of that we just use if up equal to 0, begin. If reset, out equal to 4 tick B0, else out equal to out minus 1, then end. And this is the end of this always block. Inside this always block we have this one, right? Begin and the end, and here is the end module. So that's it. Now just save this. Okay, so just check for the any errors. One thing what we can do means, here it is selected to implementation, select simulation, because we are just simulating in the design tool. So just okay, so we just select the okay, so this file and behavioral check syntax. So there is no any syntax error. If any error, it will display here. So now we need to create the test bench for this. That's why click on this new source and click Verilog text fixture. It will directly generate the test bench. So we write it. Okay, Verilog, click again Verilog module and counter counter test bench. Okay, counter test bench. Click next and click next, click finish. So here counter test bench, in the test bench this module, here we no need to write anything, and here just simply remember IR. Okay, simply remember IR. That means input, whatever the input is there, right, that we need to mention using the reg, that has to be reg. So in this, what is the input? So we can just copy over here, just for the reference. You can just have the copy over here. So what is the input? Clock, reset and up. So all these things has to be in the reg, all these things, and wire for the output. Okay, so this is the wire, this is the wire, 3 tick 0 of out. Okay, so now just close this, and this is the reference. Then we need to initialize, that means our counter in the test bench. For that, so what is the name? Counter, module name, counter unit under instantiation or UUT, and anything you can give here, name. Then inside this same sequence, if we follow this same sequence, we can directly write like this, or else we need to use the dot and the bracket and another method. Okay, so yes, okay, this also I'm just going to remove it. Okay, so Yes, now these two are the initialization, and here out clock and the reset and the up counter UUT, we instantiated this, and now we need to have the some test parameters like test values. So initial and begin, and here end. So one thing is we need to have the clock. So initially clock is equal to 1 tick B0, we assign this to 1 tick B0. Then forever hash 5, we consider as a 5, forever hash 5 time unit, the clock will going to clock equal to not of clock. Okay, so the clock is equal to not of clock. This is one thing. Okay, so another thing, initial, that means these are all the parallelly it has to process, initial and begin and end. So here another thing what we need to do, so first up equal to 1 tick B0, okay, and reset is equal to 1 tick B0. This is initially 0, no need to write reset equal to 1 tick B0, but okay, so we will not write this. Up equal to 1 tick B0. So for how many times? Hash, okay, let's say for 40. Okay, so for 40, that means 40 time unit, up is equal to 1 tick B0, it will up count. Then we just do the reset, reset or ESET, reset equal to 1 tick B1, 1 tick B1. So whenever the reset, okay, we can see here, whenever the if reset is equal to 1 tick B1, then this will just going to assign the out equal to 0. Okay, so here in the down count, instead of making this as 0, we just make this as a 1. Okay, 1 1 1 1. If reset, it is reset to the 1 1 1 1. Here it is reset to the 0 0 0 0. Okay, so now at in the test bench, okay, just save this, and in the test bench, reset equal to 1 tick B1. Okay, so then after hash 10, okay, so we just make like this, after hash 10 reset, again we need to reset equal to 1 tick B0. Okay, so then after hash 20, we will make up equal to 1 tick B1. Okay, so then yeah, that's enough, 1 tick B1. Then end and the end module. So now, okay, click Control S. So what is this? Click okay, so we just need to close this. Okay, now we will check this test bench and behavioral check syntax. There is no any error. So simulate behavioral model, and now we need to get the waveform. We got it, and just go to this out, and okay, so reset. Okay, so initially out is 0, and whenever the clock is 1, okay, the reset we need to set, okay, otherwise it will take the X only. So what we do means, so here at the beginning up equal to 1 tick B0 and reset equal to 1 tick B0. This we do. Reset equal to 1 tick B0. Now let's save this and run this one. So now we can see reset is 0 at the initially the out is 0, clock is also 0. Okay, so this is the initial, and now we can just have the okay, so we can just see. So here the clock, then here it is okay, so at this point we made reset as what is this? Okay, so reset is equal to 1 at this point. Up equal to 0. Okay, up is equal to 0, that's why it is counting down. Okay, up is equal to 0, that's why it is counting down. So here you can see it is counting down. Okay, so but at this point we made up is equal to 1, so it started counting up 1 1 1 1 0 0 1 2 3 like this. Okay, so I hope you got it. So yeah, this is in the output. We can see the counter in the IC design suite. I hope you understood this one. Now in the online, if you don't have this tool, what you can do means go to this edaplayground.com, and in the design or SV, we need to write. Okay, so for a time being I just copy this test bench here. Okay, so first we need to write here. First we need to write in the here code your design here at this part. So okay, so here I have that. So this part we need to be have here. So module counter, this part we need to be have here, and count up and count down. Okay, then the test bench we need to write here. Just simply write these things. After that and here observe this setup. So here is system Verilog, and here we need to choose this one, and this time scale we just give as a 100 ms. Okay, 100 ms, and use okay, open EW wave after run. Just click on this, and these things. Okay, so this I will share in the description. This is dump waves. This is only required in this online to dump that waveform from this to the EP wave. So before this end module in the test bench, just have this. Okay, before this end module, just have this code. Then click on the okay, so click on the run. Go here and click run, and let's check. Okay, so okay, so okay, we just run. Okay, it is running. Then it may give the result. I will just zoom this. So it is running. Okay, we just gave this as a 100 ms. I think that is more. So we just stop this, and 10 ms, that's fine. Okay, click run. So now let's see. So we need to get the waveform after some times. It is in nanosecond maybe, so that's why it is taking that much time. Let's see here. So the time unit. Okay, so here time scale is 1 nanosecond per 1 nanosecond. That's why it is taking that much time. So we can just give 200 nanosecond. Okay, just give 200 nanosecond and click run. So now this gives the waveform, and here we can see the waveforms. Okay, so I guess you can see this. Yes, now it's properly visible. We can see here. We can just change this to binary or okay, yeah. So here we can see initially it is from here 1111 1110. It is the uh, it is counting down, and after this up is equal to 1, it start counted up. Okay, up down counter, and whenever the reset is equals to 1, it just become 0. Okay, whenever the reset is equals to 1, so now okay, so we just see this code again. So if up equal to 1, okay, if reset then tick 0, otherwise so out equal to out plus 1. One thing we can do, so initially, okay, always say at passage of clock begin. Okay, yeah, that's fine. So we can just have here in the test bench if we want, so up equal to 1 tick B0 and the reset equal to 1 tick B0. Just have the reset one time, just have the reset, and reset equal to after just one clock pulse, just make the reset, otherwise it will not going to start till the reset. This is because see, until reset this out will not going to equal to 0. It will have some z value, so incrementing z means it is always z only. That's why just have the reset at the beginning. Okay, reset equal to 1 tick B1 at the beginning. Okay, just reset equal to 1 tick B1. This also fine. Yeah, I hope you understood how this counter will going to work. Thank you.